a cube is cut into 64 equal cubes. Now from each side of the original cube, second and third small cubes are removed. Now the whole thing is painted black. Then he says number of cubes which are not painted, number of cubes which are painted in one face. If you look at the remaining questions, number of cubes which are painted two faces, number of cubes which are painted three faces, number of cubes which are painted in more than three faces. So basically he's asked us 5 questions, all based on different number of faces painted, right? 0 faces painted, 1 face painted, 2 faces painted, 3 faces painted, and more than 3 faces painted. What is the data behind this? A cube is initially cut into 64 equal cubes, 64 smaller cubes. Then from each side of the original cube, second and third small cubes are removed. Now you need to understand what is the meaning by side here. See, side here refers to edge. You understand? Side here refers to edge. This side is nothing but edge. So from each edge of the original cube, second and third small cubes are removed. Because for you to count the second cube or the third cube, you have to go by edge only. You cannot go by side, or you cannot go by face. You understand? I mean, basically the point is side cannot be taken as face. The side is not face. Side does not mean face. Side means the edge. I mean, that's what it means. Otherwise, it makes no sense, right? Then the whole thing is painted black. Now the whole thing is painted black. So now after removing the second and third cubes from each edge, the whole thing is painted black. Based on that, we have to visualize the figure and answer the questions. So first of all, let us understand what actually happens here. I'll try my best to draw a neat figure, nice figure as close as possible to what is explained here, and explain you the concepts, right? So first of all, let us understand what happens. So there is a larger cube. This is a larger cube, right? Now this is cut into 64 equal cubes. 64 equal cubes is what? On each side there will be 3 cuts, right? Like this is one face. This is the front view, let's say, right? Front view. So make 3 cuts, 1, 2, and 3, right? Then 1, 2, and 3. Remember, this is one face. This is only one face, the front face. So how many cubes do you find here? 16. 4 by 4, 16. And there are 4 such portions behind, 3 such portions behind. So 16 into 3 makes it 64. You understand? So if I have to get the 3D view, it will be like this, right? See, yeah? How will it be? It will be like this. Okay. Please don't go and comment on my drawing skills here. I'm just trying to, yeah. I think the whole line will get erased. Yeah, so this is the 3D view. Again, what I've shown you here, sorry, I'm like spending time here in drawing this so that it becomes easier for you to visualize. Otherwise, you don't have to be so precise and neat in the exam. You won't be awarded marks for your writing or drawing, right? But the whole idea is visualization becomes easier. Okay. Now, so this is the front face, and then that's the back, right? So again, let me explain you the 64 cubes. 1, 2, and the third cut. I know the right hand side doesn't look like all our exact cubes, but yeah, this is the 3D view. You're getting it? Please don't comment on my drawing. Yeah, but that's close to the 3D view of the figure. Yeah, so 64 cubes, you can understand now, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 on this block, then 16 in the second block, 16 in the third block, and 16 in the fourth block. So, sorry. Yeah, 4 blocks. So 16 fours, 64 cubes. These are the 64 equal cubes. Now what is done? Now from each side meaning each edge. How many edges a cube has? A cube has 12 edges, right? 1, 2, 3, 4, 5, 6, 7, and 8 there in the background. And then 9, 10, 11, and then 12th one which is hidden here, right? I mean, hidden here is not clearly visible. So basically 12 edges. From each edge, the second and third small cubes are removed. The second and third, why is the pen not working? Sorry. Okay, hold on. The pen has stopped working for some reason. The second and third small cubes are removed. Why, Baba? Please work. I have already spent so much time in drawing this. Yeah, second and third cubes are removed, right? So second and third meaning, now this is the edge. Let's say this is the edge, right? So the second cube and the third cube are removed. This is first, second, third, fourth cube. So from this edge, second and third are removed. Similarly, if you look at this edge, the vertical edge, first cube, second cube. So this is removed, this is removed. From this edge, second cube and third cube are removed. From the bottom edge here, the second and the third cube are removed. From this edge, the second cube and third cube are removed. From this edge, the second cube and the third cube are removed. Second and third. You understand? Second and third. From back edge, the second cube and third cube. Similarly, from all the 12 edges, the second and the third cubes are removed. Now, removing as in if I try to erase, the whole figure will get erased, right? What I'll do is maybe use some color to explain you what has happened, right? Let me use red color for the cubes which are removed. So anything that is in red does not exist. You have to just visualize that way, right? So I'm just filling it up. So this portion is not there. You got to understand that. Right? Similarly here, this is removed. I don't know if there's a better way of drawing it, but I'm just trying to explain you what portions are cut out. Again, this would take some time for explanation. Please don't mention that you have spent so much time in answering this, because I'm sure you will not do this drama in the exam, right? I mean, if this is the idea, please don't do. I'm just trying to help you visualize it easily. Yeah. Then these two will not be visible. I mean, let me do the whole stuff. To be honest, I've started enjoying this coloring. I think I should spend some time doing this. This is like one meditation, right? Yeah, so this portion is gone. Here, this portion is gone. So basically, that red does not exist. It's hard to visualize that way, but yeah. So only the remaining blocks are available. So if you have to ask you how many cubes have been removed, tell me how many have been removed. So there are 12 edges. From each edge you have removed 2. So 24 have been removed. Yeah. I think we're done. All these are gone. Whatever is there in red does not exist. Only the whites are there. And these whites have been painted black. Now I'm not going to paint it black. You can visualize that anything that is in white here is painted black, right? So understand that the number of cubes that have been removed, right? How many cubes have been removed? Number of cubes removed is equal to 12 into 2. Why am I doing 12 into 2? There are 12 edges in a cube. 12 times 2. 12 times 2 is 24. So 24 cubes have been removed. And these 24 have not been painted. Right? These have been removed. Only the remaining part is painted. Only the remaining part is painted. Yeah? Now again, if you see each face, yeah, each face, how will each face look like? Each face will look as follows, right? So there are, I'm showing a face view, right? You understand? This is the front face, let's say. Not front face, but each face. Each face would look like this. And then there is this. Yeah. Here also we have this. I don't know how the diagram will be drawn to show the gap there, but you know, this is what each face would look like. Yeah. So something like this. I mean, this is from the top. When you look at it from the top, this plus, right? Otherwise, this is the front face. So this visualization is very, very important. If you cannot visualize that, then it will be difficult to answer. So what have we done? We have painted all the faces. I mean, we have painted the remaining part black, right? Remaining part has been painted black. Okay. So now let's answer the questions. Yeah. So let's take the first one now, right? The first question, number of cubes which are not painted. Number of cubes which are not painted. Now this is a very easy question to answer. I mean, we have discussed such questions in our video of cubes as well, right? I mean, if you refer to the video of cubes, let's say, forget about this cubes getting removed, second and third cubes getting removed. Forget about that. Even if the whole thing is there and everything is painted, if the original cube with 64 pieces, of course, is painted on all the sides, what will be the number of cubes which are not painted? See, we know that this has been discussed. See, what is the size 4? 64 means what? 64 is nothing but 4 into 4 into 4, right? 4 into 4 into 4, 4 cube, right? So number of cubes which are not painted can be counted as follows, right? 4 minus 2 whole cube. There are 4 cubes on each edge, on each set, we can say, right? The size is 4 by 4 by 4, right? So what happens is, for you to find out the number of cubes which are not painted, you have to exclude all the cubes, all the face, I mean all the front cubes from each face. So basically you are removing one cube from right side, one cube from left side. You understand? Similarly, one cube from left side, one cube from left side, one cube from right side. So basically the size gets reduced by 2. 4 by 4 by 4 will become 2 by 2 by 2. What is 2 by 2 by 2? This is equal to 2 cube. 2 cube, which is 8. So basically only the inside cubes, you understand, only the block which is remaining inside, all the other sides are, I mean all the complete external portion is removed. Only the blocks which are remaining inside are not painted. Yes or no? Only the blocks which are inside, completely inside, are not painted. Meaning this, what comes after this portion onwards. I'm not able to draw that. I mean, like I said, drawing would be difficult, but yeah. Those 8 cubes will remain unpainted. Plus, I think now this is a question confusion here. He's asked us to find out the number of cubes is not painted. 8 cubes are definitely not painted, which are inside, right? Plus, there are how many cubes which have been removed? 24 cubes have been removed. So these 24 should also be added. You're able to follow? So what we have calculated here is inside cubes. Inside cubes are 8. Totally which are not painted. Totally which are not painted will be equal to this 8 cubes which are inside plus these 24 cubes which have been removed. I'm sure some of you will say 8 should be the answer because those have been removed. Of course they have been removed, but they have also not been painted, right? Number of cubes which are not painted. Before painting we had removed the cubes. How many cubes are removed? 12 into 2, 24. 24 plus 8 cubes which are inside are not painted. So 8 plus 24, 32. You getting it? So I think the answer to the first question has to be fifth option, none of these. None of these. Again, there are different views. I think some of you will say 8 should be the answer. You have to understand the point that I'm trying to make, right? Answer would be 8 if we exclude these 24 cubes. But in my view, those 24 should also be included. So 8 plus 24, 32. The number of cubes which are not painted is 32. Yeah. Let's go for the next one. Number of cubes which are painted on one face. Number of cubes which are painted on one face. See, understand that out of the, if you have removed 24 cubes, how many cubes are there in the figure? In this figure, the pen is also stopped working in the wrong time, right? In this figure, if you see, number of cubes which are remaining, how many are remaining? See, total was 64. From 64, I have removed 24. 64 minus 24, 40. So basically 40 cubes are remaining in the block after these edges are removed. I mean, after the second and third cubes are removed. Now, from these 40, he says how many cubes are painted one face. See, of course, these 24 which are removed are not painted. How many are there where one face is painted? How many are there where one face is painted? Try and understand. Will there be any cube where one face is painted? Try and look at this big figure, right? See, all these 4 cubes are painted on one face. Number of cubes which are painted on one face. If you observe these 4 cubes, you may feel that okay, these 4 have been painted only on one face, only on the front face. But actually, these 4 have been painted on more than one face. Why? See, these 2 have been removed. These 2 cubes here have been removed. That means the top of this, let me say these cubes are A, B, C, D. So because these 2 have been removed from this edge, the top face of A is visible, the top face of B is also visible, and that also gets painted. So basically A and B have been painted on more than one face. Similarly, the right hand side of B is available, this side of B is available, right? This side of A is available. Because these cubes have been removed, this left hand side face of A is available, right hand side face of B is available. So that also gets painted. So basically A and B have been painted on more than one face. He's asking us to find out the cubes which have been painted only on one face. Yes or no? Cubes which have been painted only on one face. A and B have been painted on more than one face. Similarly, C and D also have been painted on more than one face. See, the bottom, the base of D and the base of C will be visible because these two cubes have been removed. Their bases will be open for painting. Similarly, the right of D and the left of C is open for painting. So A, B, C, D all have been painted on more than one face. A, B, C, D have been all painted on more than one face. Yes or no? And clearly the cubes on the edges, like for example, if you say E, F, G, H. E has been painted on three faces, right? Any cube which is on the corner, not the edge, but the corner. Any cube which is on the corner is painted on three faces, right? E's front is available, top is available, left is available. F's front is available, top is available, and right is available. Similarly, H's right is available, base is available. G's base is available, left is available. So these cubes also have been painted on three faces. In fact, not even three, they have been painted on more than three faces, right? The left of F is also available because this side is open. The right of E is also available because this side is open. You're getting it? So basically the idea is number of cubes which are painted on one face. If I see these cubes are painted on more than one face, these cubes A, B, C, D are painted on more than one face, E, F, G, H are also painted on more than one face. And those which are inside, those 8 cubes that we had counted, right? These 8 cubes are not painted at all. So basically there is nothing left which is painted on one face. No cube is painted on one face. So answer should be 0 for this question. There are 0 cubes which are painted on one face. You're getting it? 0 cubes which are painted on one face. So I think the understanding here is this ABCD type of cubes, right? These ABCD types, which are the middle of each faces, right? ABCD types are painted on how many faces? ABCD types are painted on, I told you, A's top and left is available, B's top and right is available, D's right and bottom is available, C's right and left and bottom is available. So each of these cubes is open on 3 sides. So 3 faces painted. 3 faces have been painted. Right? Similarly, EFGH types. EFGH types are all corner cubes. Why is the pen not working again? EFGH types. Right? How many are painted? EFGH types I've already explained you. For F, front is available, top is available, right is available, left is also available, and see this side back is also available. The back of F is also available. Only the base is not available for F. The other 5 sides are open, right? Front, right, left, top, and the back is available. So 5 faces are painted for all the corner cubes. Usually only 3 are available, but because the second and third cubes are removed from each edge, the side of F, left side of F and the back side of F gets open. So 3 plus 2, 5. It becomes 5. Similarly for E also, front is available, top is available, right? Left is open, right is open, left is open. So 1, 2, 3, 4, and back side is open. So 5. So for each corner cube, 5 faces are open. So EFGH types, all the corner cubes, 5 faces are painted. All the center middle cubes, A, B, C, D, 3 faces are painted. All those are which are inside these 8 cubes, 0 faces are painted. For these 8 cubes, 0 faces are painted. Inside cubes, right? Inside cubes, I've already mentioned. Sorry, the pens stopped working. Hold on. Zero faces painted. Okay. Of course, the total number of faces, cubes with 0 faces are painted. No cubes, no faces painted were 8 plus 24. That's why we marked 32 as answer here. But otherwise, inside cubes 8. So I think once you've got this clarity, answering the question becomes easy. So 0 faces painted, 32 cubes. 1 face painted, 0 cubes. Now 2 faces painted. 2 faces painted. Tell me how many cubes are there where 2 faces are painted? There won't be any cube where 2 faces are painted. What are the types of cubes that we have? The cubes which have been removed. The cubes which have been removed, not painted at all. The cubes which are inside, not painted at all. The cubes which are, ABCD types, 3 faces painted. The cubes which are EFGH types, 5 faces painted. And I think this covers all the cubes. See, 24 plus this 8, 32. Right? ABCD types, how many cubes will be there? ABCD, each face has 4. Each face has 4. How many faces? 6 faces. So 4 into 6, 24. There are 24 such cubes. Yes or no? EFGH types are how many? 8. These are corner cubes, 8. So if you see all the 64 cubes, right? All the 64 cubes have been counted. 24. This 8 I wrote long back, it is not reflecting. Let's wait for that. Yeah, it has come now. So if you see, I'll show you the balance, I mean the total of 64. The 64 cubes are what? 24 which are removed and not painted. Then 8 cubes which are inside and not painted. 24 these cubes which are ABCD types, right? Each face has got 4, 6 faces, 24. And corner cubes, EFGH types. So you see totally 64. 24 plus 8, 32 plus 24, 56 plus 8, 64. So if you see, we know how many faces painted, right? Out of 64 cubes, there are 24 cubes which are painted on 3 sides. There are 8 cubes which are painted on 5 sides. There are 32 cubes which are not painted at all. So if you go to the next slide, you know the other 3 questions. What is the next question? I mean, if I go to the next slide, the figure will go off. That's the reason I'm not going there. But if you see, next question is 2 faces painted. Let me change the color, sorry. Yeah. So question number 3 is 2 faces painted. 2 faces painted, 0. Right? There is no cube where 2 faces are painted. So this will be equal to 0. Yeah. 3 faces painted. 3 faces painted. How many 3 faces painted? See, 3 faces painted we have already counted, 24. And the last question was more than 3 faces painted. Sorry. 3 faces painted, 24. And last question is what? More than 3 faces painted. More than 3 faces painted? These 8, where 5 faces have been painted. So I think on the next slide, the answer should be 0, 24 and 8. 2 faces painted 0, 3 faces painted 24, more than 3 faces painted 8. Right? So number of cubes where 2 faces are painted 0. Number of cubes where 3 painted faces 3 faces painted 24. Number of cubes are painted on more than 3 faces 8. Right? All the corner cubes. Right? 3 faces painted are all ABCD types. You know, the middle cubes on each face. Right? 2 faces painted 0. There is not even a single cube where 2 faces will get painted. All right. So answers are 0, 24 and 8. Yeah. So I quickly summarize. Number of cubes which are not painted at all, 32. 32 because 8 inside cubes are not painted and 24 cubes which are removed are not painted. Number of cubes which are painted only on one face are 0 because there won't exist any such cube. Number of cubes that are painted on 2 faces are 0. Number of cubes that are painted on 3 faces are 24. Number of cubes that are painted on more than 3 faces are 8.